Hello dear learners, you are welcome to mathematics class on Eko Learners Support for WAEC and NECO candidates. In today's mathematics class, we'll be looking at concept of number base. So sit back, let's learn together. Number base. So our learning objectives that by the end of this class, we will understand what number base means. We convert from any base to base 10 and convert from any base to non-decimal base. By non-decimal base, we mean to non-base 10. So let's take it quickly. What do we call a number base? A number base is the number of digits or combination of digits that a system of counting uses to represent number. Let's say, for example, in our natural counting, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we'll go back to 11. So at that natural counting, that is base 10. Because we count in 10, 10. 10, 10. That is base. Probably you've gone to market especially where they sell maybe yam or some product in which they will tie it 3, 3, 5, 5, 7, 7. So if it is tied 3, 3, that means that base system is base 3. If it is 5, 5, that is base 5. So that is what we are looking at here. Number base is a system of counting natural numbers in bundles. So you've gone to buy something, when they say 1 dozen, right? 12. That is in base 12. So for instance, numbers are counted in bundles of 10 digits called base 10. That's our decimal system. Or denary. The digits involves in English natural numbers. So we count numbers in 10. So our natural counting starts from 0, 1, 2, 3 down to 9. And when it gets to 10, you represent that 10 with 1 and 0, which is still part of what we have here. So if it is in any other base, such as binary 2, octa, that's octa number system, that's 8, decimal 10, hexadecimal 16. This is very common in computer system because all the information on computer system are represented in 1010, so they use binary often. It doesn't mean that these are the only bases that we have. It can be base 3, it can be base 4, and so on. We'll understand it better. Let's pick the simplest one, binary number. Binary numbers are system of counting numbers in base 2. And when we are counting in base 2, we can only have 0, 1. So instead of counting 2, you go back. That will become 1, 0. So that is a system of counting. If you are dealing with base 3, your counting will be 0, 1, 2. When you want to write 3, you will go back to 1, 0. That will give you 3. So the system of binary number is what we have here. 1, 1, 2. This and this. This 1, 0, 1 means another thing in binary if we change it to our natural base 10 counting, which we understand by the end of today's class. So looking at this, we want to look at how to convert a number-based system from one base to another. Let's first understand that in our binary now, which is base 2, the highest number you can have there is your 1, because it will start from 0, 1. If we are dealing with base 5, now look at it, base 5. Base 5, you get to have 0, 1, 2, 3, 4. So instead of writing 5, if your counting is once, you now turn it to 1, 0. So 1, 0 is your 5. If you are to convert 6, that is in base 10, to base 5, so you know what it becomes. It becomes 1, 1 in base 5. The same way in binary. So this one says we should convert the following number to base 10. This one is in base 2. If you are converting it into base 10, that means we are going to be multiplying each of the number by the base. We multiply each of the number by the base. What am I saying? It will become 1 multiply by 2, then plus 0 multiply by 2, plus 1 multiply by 2, plus 1 multiply by 2. So you realize that 1, 0, 1, 1. I will now do something. From the last one, I'll give it a power of 0, 1, 2, 3. So it is this that I will now express that will take this to base 10. So that is how we convert to base 10. For the second one, 34 base 5, if I'm to convert this to base 10, it's going to be 3 times 4 plus, it's going to be 3 times 5. We multiply by the base. 3 times 5, remember it's base 5, plus 4 times 5. Once we are done with this, we now start. You give the base power of 0 from the right hand side, 1. So if we simplify this, whatever this gives us, for example, this become 5 raised to power 0. Remember, that will be 1. Multiply by 4. That was 4. Plus 5 raised to power 1. 5. Multiply by 3. And that is 15. So when you add this, it gives you 19. That means this 3, 4 in base 5, not 34, 3, 4. This 3, 4 base 5 can be expressed as 1, 9 base 10. And that is what we have done here. So this one is the same thing where we have done here. Let's look at the solution here. Here we have it to be equals to, you know the process, 1 multiplied by 2 plus all that, and that is what we have here. So let's look at this. The next thing is that we then begin to look at the power of each of it. 2 raised to power 0, 1. 2 raised to power 1, 2. 2 raised to power 2, 4. 2 raised to power 3, 8. Then we simplify this. When we simplify it, we have it as 11 in base 10. That means 1, 0, 1, 1 in base 2. If converted to base 10, it becomes 11. It is at this point that you can say 11 because that's the natural counting. But if it is in base 2, it's not 11, it's 1, 1. And let's quickly look at it. So if this is 1, 1 in base 2, what do you think it is? Remember, this 1, 1, 1, 0 in base 2 is our 2. So adding another 1 to it now to make it, and that's 3 in base 10. That is how it is done. Conversion from one base to decimal. When we say decimal system, that is base 10, which we have done here. So you may want to look at other numbers. If I give you this, 2, 3 base 4. You know what to do to that to convert it to base 10. It's going to be 2 multiplied by 4 plus 3 multiplied by 4. Then you give that 4 power of 0 from the other side to 1. Good. That is exactly how we do it. So let's look at conversion, another way of converting, that is conversion to another system. Other number-based system to non-decimal. When you are converting from any base system, either base 2, base 3, base 4 to base 10, so simple, you just multiply the individual digit by the base and give it that power. But if you are doing it to non-decimal, that is non-base 10, now this is how we move. You convert the original number given to you to decimal number, that is, you first take it to base 10, then from base 10, we take it to the new base. Let's say I want to convert this base 2, I want to convert it to base 5. I cannot go directly from this base 2 to base 5. I will first go from base 2, it will branch at base 10, which is like the kingdom there, they stay there. You must first get to base 10. Then it is whatever value it is in base 10, you now take to base 5. Is that taken? So when you are converting from one base to another base in which it is not base 10, you first take it to base 10 before you take it to that number. So let's look at an example. Here we are to convert 134 in base 5. 134 in base 5, we are converting it to base 8. We want to convert this to base 8. So that means we first take it to base 10 before we take it to base 8. We've learned how to convert in base 10. That's just 1 multiplied by 5 plus 3 multiplied by 5 plus 4 multiplied by 5. Then we give it power of 0. That is, we are giving the base 5 power of 0 from the right hand side, which it becomes something of this nature. The very first step 1, convert to base 10. So let's look at how it is done. You see, we convert it to base 10, 5 raised to power 0, 1, 5 raised to power 1, 5, 5 raised to power 2, 25. So we simplify that, which I believe that we are loaded with that. So when we simplify that, at the end, whatever it gives us is expressed in base 10. So this gives us 44 in base 10. Now we've taken it to base 10. Remember, that's the kingdom. So from there, the base 10, we are now taking it to base 8. How do we then move from base 10 to any base? And one of it is what we want to do. How you move from base 10 to any base. So to do that, we want to convert that solution. Remember, we are going to base 8. We want to convert that to base 8. So how do we go to base 8? 44 base 10 to base 8. 44 in base 10. We want to take it to base 8. To do that, just like we do our LCM, we rule something here. It's very easy. 44 is already in base 10. We want to use base 8 to change it. So we use 8 as here. 8 goes in 44. How many times? Correct. 5 times. So 5. It remains what? It remains 4. So you keep your remainder 4. That remainder is what we keep here. So 8 goes here. Can 8 go here? No. You return the 5. It will go there 0. Remainder what? Remainder 5. 8 goes here, remainder 5. So now we will now take this reading upward from here. Upward. That means 44 in base 10 is being converted to 54 in base 8, which then take us back to what we are converting. That means our 134 base 5. 134 base 5 into base 8 gives us, so 134 base 5 will be equivalent to 54 base 8. 54 base 8. So it's more or less like when you have a tiny bucket, you pour water into it. When the water is filled to the brim, that bucket is full, right? Do you know that the same water that you consider full in one bucket, if you pour into another bucket that is wide, that bucket will just swallow the water and you look like that. So the water is small. So that is the system of number base. This makes it appear one big figure, 134 base 5. But when converted to base 8, you see what it becomes? So that is just the knowledge of conversion from any base to this. And that is basically what we have come to revise our memory on in this binary, in this number-based system. So I will leave you with this practice question. You are to express 215 in base 6, take it to base 10. That is so simple. And you will now express this in base 5. So I'll give you a few minutes to try that out.
Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
All right. I want to believe that you enjoy your time trying it out. That shouldn't be a problem again. So we are going to be taking the solution together now. Let's look at the solution to practice question one by one. We are to express this in base 10. Base 10. So easy. You multiply individual digits by the base, then give it power of 0, 1, 2 from the back, which is 2, 1, 5, base 6 equals, we are doing this together, remember, 2 multiplied by 6 plus 1 multiplied by 6 plus 5 multiplied by 6. Now that we have expressed this, we now give it power from here, the base, 0, 1, 2. So doing that, it's going to be 2 multiplied by 6 raised to power 2. That's 6 square, 6 times 6, not 6 times 2. 6 times 6, 36. Plus 6 raised to the power of 1 is 6. That's 1 times 6 plus 5 times 6 raised to the power of 0. Remember, anything raised to the power of 0, 1. So we can simplify this to be, when you multiply this, it gives us 72 plus 6 plus 5. It's looking like what you have gotten, right? Fantastic. So this one gives us 11 plus this, and this gives us 83 base 10. So look at this, 215 that appear very big to us. Now turn to base 10, it becomes 83. Isn't that fantastic? Good. So I want to believe you go through this, and if there is any mistake in what you have solved earlier, you correct it. Let's take solution to the question number 2. Express 10110 base 2 in base 5. Remember, you are moving from base 2 to another base, which is not base 10. So for you to get there, you first take the base 2 to base 10, then you pick it from base 10 to the base you're going to. Good. Let's quickly rush through that. So in going from 10110 base 2, we first express in base 10, which is 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2. After doing that, we give that power to the base, 0, 1, 2, 3, 4. Interesting. You did something like this. Now let's begin to simplify. 2 raised to power of 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So that is 1 multiplied by 16 plus 2 raised to the power of 3, right? That's 8. That will be 0 times 8 plus 1 to the power of 2, that's 1 times 4, plus 1 to the power 2 raised to power 1, that's 2, plus 0 times 1. 16, this one ends up being 0 because of multiplication of 0, plus 4, plus 2, plus 0. So when we had this, 16 plus this, that's 20, so we have it as 22. So it is 22 in base 10. Remember, we have gotten to base 10. Now it is from this base 10, we now move to base 5. So we are converting 22 base 10 now, 22 base 10 to base 5. To base 5, which I've told us earlier, that is so simple. Draw your line in this way. It's the simplest approach you can have with it. 22 is in base 10. So you are moving from base 10 to base 5. So you put the number in base 10 here, the base you are going to, you put it here. 5 goes in 22. 4 times remainder 2. It remains 2. Keep your remainder here. 5 goes in 4. It will not go. 0. Remainder what? It returns your 4 to you. Is there anything to solve again? No. So you pick your reading from here, upward. It then means 22 base 10 is expressed as 4 to base 5. Remember, this is our main question. Therefore, 1, 0, 1, 1, 0 in base 2 is 42 in base 5. So this 1, 0, 1, 1, 0 is actually 22 in base 10. Isn't that interesting? So if you have gotten this, that means you have added something to yourself today.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So for any question, complaint, or suggestions, you can reach us on our social media handles being displayed on your TV screen. Till we come your way next time, remember, maths is fun.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.